Okay, folks, so today we're going to be looking at different ways to find or calculate delta G quantitatively. So far, we have just been predicting the sign, whether delta G is positive or negative, based on the sign of delta H and delta S, but we can also calculate it quantitatively. The stuff that we're going to talk about today are located in section 18.7 and 18.8 in your textbook. So the first way that we can calculate delta G is by finding delta H and delta S separately and then plugging them in along with temperature to the equation delta G equals delta H minus temperature times delta S. The other way is by using standard free energy values, which are located in the back of your textbook in Appendix 2. And the third way is using those standard values for different reactions and the concepts of Hess's law. So I'm going to talk today about finding delta H and delta S using the delta G Gibbs free energy equation, and Mr. Johnston is going to go through how to use delta G with the standard values. So first, just a review of how to find delta H and delta S. These two equations are located on your equation sheet. We used this equation way back in thermochemistry for delta H. And so we said this change in enthalpy of a reaction is going to be the sum of standard enthalpy of the products minus the sum of the standard enthalpy of reactants. So that degree sign means standard. So that's that standard kind of pressure and temperature. We can do the same thing for delta S. So it's going to be the change in entropy for the reaction is going to be equal to the sum of entropy for your products minus sum of entropy for the reactants. When you're doing these, remember you do have to account for the number of products and reactants, so multiplying by coefficients. And then just so you're aware, we can also find delta H with bond energy calculations. So check out section 9.10 in your book to review that. So we're going to check out an example question. Our example question is going to be to find delta G from our standard delta H and delta S values at 25 degrees Celsius and 1 atmosphere. So for the reaction, 2 SO2 gas plus O2 turns into 2 SO3. So what we have in this table are delta H and delta S values. These are from Appendix 2 in your textbook, so if they're not given to you, you need to look them up. And we need to use this to figure out delta G. So we're going to try to find delta G from this information. So the plan is, in order to use this equation to solve for delta G, we need to find each of the variables. So the first thing I'm going to do is I'm going to find delta S using delta S reaction equals sum of products minus sum of reactants. We need to do the same thing to find delta H. And then the tricky thing about H and S is that if you notice here, the units for enthalpy are always or most often in kilojoules, where the units for entropy are in joules. So once we have found those values, we have to match our units. It doesn't matter which way you go, whether you convert to kilojoules or to joules, but it's very important that you match your units to be the same thing. We also need to convert our temperature unit into Kelvin, and then we can go ahead and plug in and solve. So I would recommend pausing the video and trying to do this first, and then coming back and see if you match my answer. All right, so hopefully you've tried it. Let's check out how to do this. So change in entropy, that's supposed to be an S, it's going to be sum of products. So there are 2 moles of SO3, so I'm going to take 2 times 257, the entropy for SO3. It's the only product. And I'm going to subtract the sum of enthalpy of the reactants. So 2 moles of SO2, so 2 times 48, plus 2O5 for oxygen. And it's going to be the total of that. and then you subtract that value and you get negative 187 joules per Kelvin mole. I'm going to do the same thing for delta H. So delta H, there are two SO3 molecules that have negative 396. Gotta watch your negatives in this one. I'm going to subtract the sum of my reactants, so 2 times negative 297 plus 0. So 2 times negative 396 minus 2 times negative 297, and you get negative 198 kilojoules per mole. I need to convert this to joules so my units match. Again, it doesn't matter which way you go, but I'm going to joules. Kilojoules are currently on the top, so kilojoules go on the bottom, and there are 1,000 joules in a kilojoule. And so if you multiply that through, don't lose your negative, you get negative 1.98 times 10 to the 5th joules per mole. The last conversion I need to do is temperature. So temperature equals Celsius plus 273.15. So you get 298.15 for Kelvin. So then we're ready to plug all of that information into delta G. So delta G equals that negative 1.98 times 10 to the 5th joules per mole minus 298.15 Kelvin times negative 187 joules per kilomole. I like to write my units in because then I can make sure my units all match. So Kelvin cancels, and you're left with joules per mole minus joules per mole, which will make my answer joules per mole. And so here my answer is negative 142245. If I think about significant figures, I just kind of thought temperature, or I guess 1 atmosphere would even just be one significant figure. So my answer is negative 1.4 times 10 to the 5th joules per mole. Or if you were in kilojoules, it would be negative 140 kilojoules per mole, or I guess negative 100 if you're going to one significant figure. So for these calculations, you need to find delta H and delta S separately using those two equations on your equation sheets. The important thing is to make sure your units match up, and then it's just solving algebra equations. There are some more examples in your reading guide to check out on this. All right, so we're going to run through one more problem on how to find delta G from delta H and delta S. So this question says, at what temperature is the following process spontaneous at 1 atmosphere? So the vaporization of bromine, where delta H is 31.0 kilojoules per mole and delta S is 93 joules per Kelvin mole. So one thing is you need to think about, when is delta G spontaneous? Hopefully you remember that delta G is spontaneous when it is less than 0. So we are looking for a negative value. So what we need to do is we need to solve delta G for when it just crosses below that 0 point. So again, my plan is we need to find the temperature where delta G just becomes negative or goes below 0. So the way we can do that is by, again, we have to match our units, delta H to delta S, because we can't use the equation unless those match up. This time I'm going to go the other way. And then what we'll do is we'll set delta G equal to 0, because then we'll know that what's called the changeover temperature, where something's going to go from spontaneous to not spontaneous. And then plug in and we'll solve for that temperature value. All right, so again, we need delta G to be less than 0, so we'll set it equal to 0 and solve to see where is that change over temperature. So the first thing I have done here is, first of all, you should pause and try it on your own and then come back. But here we are. Delta S is, we need to make sure our units match. So I'm going to convert the delta S to kilojoules. So again, there are 1,000 joules in a kilojoule, so you get 0.093 kilojoules per Kelvin mole. And then delta G equals delta H minus T times delta S. So I'm setting delta G equal to 0. I'm plugging in delta H, which we said was 31 kilojoules per mole. Subtract T multiplied by S with kilojoules as my unit, 0.093. Then I'm just going to solve algebraically for T. So I'm going to subtract 31.0 from both sides and divide. So I get this. I've subtracted 31, so I get negative 31.0 kilojoules per mole equals negative T times 0.093 kilojoules per Kelvin mole. I'm going to divide both sides by negative 0.093, and the negatives cancel. My units match. You get 1 over Kelvin, which is Kelvin, and you end up with 333 Kelvin. So what that means is that just above that 333 Kelvin, this is going to result in a spontaneous reaction because that value will make it less than 0. So it's just another way that we can use this equation to find some information about delta G and the thermodynamic favorability or spontaneity of a chemical reaction. So again, keep practicing and check out video 2 about how to find delta G using standard free energy values and Hess's law.